Hello there. In this video, we're going to look at a few other topics that came up in your overview chapter. Fundamentally, what is an interpreter versus a compiler? What are the key parts of a programming language? And then we'll probably also talk a bit about debugging because that kind of fits in with that. And I want to get through most of the materials that are in that chapter, and then we'll have a chance to talk about actual Python basics in a little bit, either at the end of this video or in a separate video. Okay, so I just have a couple of notes here. We're not really going to spend a lot of time or energy thinking about compilers versus interpreters, but it's mentioned, and it's important to know that Python is primarily an interpreted language. We talk about installing Python. That's the Python interpreter. And what does that mean? When you have a language that is interpreted, there's a program called an interpreter. You give it code, and it performs the actions that that code requires. So your code, when it runs, always depends on there being an interpreter on the machine that can run that code. If you have a different programming language that is compiled, then compilers take in a program and they translate it into a lower level form. That lower level form might even be executable on a particular computer. And if it is, then that means that that program, that executable, can be sent to other places and they don't have to actually have that compiler installed because the translation is done. In the modern era, there are so many languages that kind of blur the distinction between interpreted and compiled, because Python actually does at times create some partial programs that are compiled, and there are languages like Java where you run the program and you get something out of it, but it's not actually an executable. You compile Java code into Java bytecode, and then you have an interpreter for Java bytecode that has to be installed. It's just that it's much smaller than the compiler. So there's a lot of fuzziness around these terms. All you really need to know is that Python is an interpreted language. There is a Python interpreter that we want to talk to. And I already mentioned in an earlier video, you can either create a shell or console and interact with the Python interpreter one statement at a time, or you can write your code in a file and pass the whole file to the interpreter, and it will run all of the instructions that are inside that file. The readings also talk about key parts of a programming language, and they have this list of 5. So what do you need to, any programming language, no matter what it is going to have certain things in common. It will certainly have a way to get data into the program, so that's input. It will have a way to produce results that can be seen, that's output. It will have some way to do mathematics or logic, that's the basis for the computations, the calculations that we want to do. It will have some way to make decisions, some sort of conditional, so that the program can choose a different action based on some condition. It will also have some way to repeat things, so that you can actually tell it, keep doing these steps over and over until something happens. Any programming language, any computer is going to have these basic skills, these basic pieces. Even if you go way back in time to the old computers that were programmed by flipping switches on the outside, many of them actually had this underlying structure to them. I want to kind of pick apart that third point, the math and logic one, because if all you think about is math and sort of what you've studied in school, or you think about logic as sort of basic Boolean logic, yes, that's the foundation of everything we do. But we do a lot more with it. And you want to think broadly about what's included in that step 3 there. So I would elaborate on those steps and say that programming languages all have data. They have some way or ways to represent information inside the program so that it can be worked with. And often they have multiple data types that are built in. You also have built-in operations on those data types. So you have to be able, for instance, to represent numbers in order to do math, and the operations operate on numbers. In a typical programming language, we have other kinds of data as well. Often the second most common is characters and strings, and we'll have operations that work on those, but you can have lots and lots of other kinds of data. And we'll learn about a bunch that Python has as time goes forward. The other thing that I would include is almost all programming languages have variables, and this idea of an environment in which variables are defined. We need a way to store data that we're manipulating during the running of a program. When you're working out like an algorithm in doing a sort of a mathematical calculation like long division, you write it down, and you have partial values that you generate that you need to write down and remember in order to continue the process. We need that inside the computer as well, and we do that with a concept called variables, which are basically names for data, names for places where we can store data. And an environment is something the running program has, which is where all of the current data is stored, where are all the variables, and what is it that they contain. So those are sort of key aspects of a programming language that Python has, that Java has, that C# has, that pretty much any programming language you're going to run across is going to do these things. You might notice that this will exclude things like HTML from being considered programming languages, which I think is wise. It's not a programming language, it's a markup language, which is slightly different. All right, there's a big section, several sections actually in the chapter about debugging. That's because debugging is going to be a necessity for you. I have sort of these two main points. I think I mentioned these maybe earlier or in the previous video. Programming languages are not built for human beings. They are built as a compromise between what we humans would like to do and how we would like to describe processes, and what the computer can actually understand. So we have to do certain things in very rigid and precise ways in order for the computer to be able to make sense of what we're asking it to do. We humans are not good at being very, very precise. You will make mistakes from the very beginning. I make mistakes, and I've been programming for heavens, 45 years. It is just in our human nature that we are not as precise as programming languages require. So we spend a lot of our time when we're programming debugging our programs, figuring out what mistakes we've made, where what we are telling the computer is not what we want the computer to do. The computer will always do exactly what we tell it, but just that we may not be telling it correctly. So your book talks about, your readings talk about three different kinds of errors: syntax errors, runtime errors, and semantic errors. There are lots of other categories we can break errors into, but this is a good starting point. A syntax error is when the code you have written is not grammatical. It doesn't make grammatical sense, and the grammar of programming languages is very rigid. So your code is improperly formed and the computer cannot make sense of it. This could be as simple as leaving a dot off, or a colon, or a quotation mark. We have to be exact with where we put all of these markings, and so if you don't do that, you will get syntax errors. One of the nice things about syntax errors is that PyCharm, our editor, can often detect them and highlight them for us before we ever try to run our programs. And when I talked about like making one little change in the code and all of a sudden errors show up in the editor, that's PyCharm helping us out. Python isn't doing anything there until we run the program, and then it will generate a syntax error and tell you where it detected the error. Runtime error, this is an error that happens while the program is running. And so here I gave three examples of the kinds of things that could be runtime errors. You tried to do an operation with the wrong kind of data. So you were doing division and you passed it a string, and it doesn't know what to do with a string when it's with the division operation. So it gives you an error message. Or your code referred to a non-existent variable name. This happens often because you misspell it. So if you have a variable, my best, and in one place you spelled it my_best, and somewhere else you spelled it mybest, those are two different variables from the computer's perspective, and it will not know what you're talking about. So that's a common error that you find. Divide by zero is the classic runtime error. Yeah, if you write your code in such a way that you accidentally ask it to divide something by zero, it may not be able to detect that until runtime. But it will detect it, and that's not a permissible thing to do, so it will give you a runtime error. A semantic error, this one's more subtle, but fundamentally what it means is your algorithm is incorrect. Now, it could be that there are lots of reasons why your algorithm is incorrect. One is that your idea was wrong. Your idea just doesn't work, and maybe you just hadn't tried an example to figure out that it doesn't work. More often, you may have a completely correct algorithm, but you didn't express it correctly in Python. You did something that caused it to give a wrong answer. So semantic errors, the first two categories, syntax and runtime errors, those generate error messages that your program stops and it says something went wrong here, and it tells you what it can about what was happening when the error took place. Semantic errors, your program may run correctly and it may run and it may end without any errors being generated. It just produced the wrong answer. So there's a difference between running without any errors and being correct. And that's where semantic errors sit. So maybe you didn't express it correctly and it did the wrong calculation. Maybe you were supposed to multiply by 5, but you said +5 instead. And sometimes that's just a typo. You just typed it wrong. And sometimes it's because when you were thinking through it, you didn't realize exactly what the correct way to solve the problem was. I'm going to stop here again. So this is really a summary of the things that are most important out of your readings, plus my own commentary on those. The last thing that is left to do is to take a look at some very, very simple information about data types. I'm going to do that in another video just to keep each of these individual videos short. So I'll see you in the next video.